6.3. Today what we're going to do, you guys, is we're going to look at square root functions and inequalities. So the interesting thing that happens with a square root function is we now know that we can't take the square root of a negative number in the real number system. So if I'm going to just look at like the square root of x, for instance, this guy is going to start here at 0. So if I plug a 0 in there, I actually get a 0 out, right? If you say this is y is equal to this thing. At 1, we'll know we'll be at 1. But if you plug a negative 1 in there, notice you're not anywhere. You're not in the real number system. So unlike the x squared function that looks like this, which has a mirror on both sides, y equals the square root of x only is going to come up on one side. So it's still acting a lot like the y equals x squared inverse, because the square root of x is actually the inverse of x squared. The problem is, if we don't have a plus or minus out here, we only look at this part of the graph. Okay. If you have a plus minus out front, if you have a negative applied on the outside, then obviously we can do the other half of this thing going this way. All right, so that's the square root of x function. Now what I'm going to do, the method that I would prefer to teach you here is, let's start with this idea, and then let's use our transformations, which we've studied and which you did a lot with in your art projects already. So the square root function, if a function contains the square root of a variable, it is a square root function. All right, that makes sense, right? Easy enough. Does that even need to be said? I don't know. But parent functions of square root functions. So here you go. This is the y, or f of x, is equal to square root of x. This is the parent function. This is what it looks like. Okay, a couple things about this. The domain, or the possible x values, are the things that are bigger than 0, right? So I'm not going to be plugging a negative back into that thing. The intercepts of this thing happen at 0, 0. Just that's the only intercept that happens on the parent function. If x is less than 0, we're not defined. So back here, right, when x is less than 0, we don't have a picture. And then for the end behavior, we know that x is going to 0 as f of x goes to 0. So what that means is, as we're going this direction, right, as x goes to 0, so does our function. And then as we go to infinity, so as we go the other way, as we go this way off to infinity in the x direction, we also go to infinity in the y direction as well. All right, just very, very slowly as we go on. So the domain and the range. Remember that you can't take the root of a negative number in the real number system. So domain must only include numbers that keep the radicand positive. All right, so we begin with whatever makes what's inside the radical positive. This thing has to stay positive. So for example 1, notice here now, okay, we have x minus 3 inside of the square root function. Remember that whenever we have something inside a function, it shifts things on the graph left or right. Okay, so let's just take a look at this. If I plug in, by the way, the thing that makes this thing go to 0 is a positive 3. So that's how it's going to shift 3 spaces, but which way does it go, right? So that's the question. Well, let's plug some things in here. If I plug a 0 in there, by the way, notice what happens if I plug a 0 in. If I plug a 0 in for x, I get the square root of negative 3 out. That is not in the real number system, so we're not going to be graphing that here. Okay, so that doesn't work. That's undefined. And in fact, 1 and 2 would also be undefined, but 3, what happens when I plug a 3 in? I get 0, square root of 0, 0. So at 3, I am at 0. Okay, if I plug a 4 in, I get a 1 out. Okay, so at 4, I'm at 1. And now notice we just have the whole thing, the parent function, shift 3 spaces to the right. And if you go on Desmos, you can plug that in and you can see that. All right. So that's example 1. Oh, it says to identify the domain and the range. Okay, well, the domain is going to be the x values where x is greater than or equal to 3. And the range which is the y values, will be the y values where y is greater than or equal to 0. Okay. Next we have this guy. Notice we have a shift to the left 6 because this is a positive here, and then we also have a shift up 2. So that's our transformations happening. So without doing much work, okay, if you understand this concept, you would know that this thing is going to start right here, and then it's going to behave like it always has, and it's going to do something like this. Okay, if you don't see that, I encourage you to make an XY table for this. Notice what happens when I plug in a -6. -6 plus 6 is 0. The square root of 0 is 0. 0 plus 2 is 2. So at -6, I'm at 2. Okay, then if I plug in a, let's go ahead and plug in a -5. So at -5 plus 6 is 1. Square root of 1 is 1. 1 plus 2 is 3. So at -5, I'm up at 3. Okay, so you can kind of see how that works. But you can also just use your transformations. So the domain here is going to be the x values where x is greater than or equal to -6, and then the range here is going to be the y values where y is greater than or equal to 2. All right. So here we go. Transformations is what I've already been hinting at. Desmos is a really good resource for this, where you can check these and play with these a little bit, but you've done that already. Hopefully in your projects you did something like this. So remember that if something happens inside the function, okay, so here that's represented with x minus h, it's a horizontal translation. It's moving left and right. Whatever makes that thing go to 0 is how it moves. The vertical translation happens with the, in this case it's called k, but it's the thing that happens outside of the function. So when you add or subtract something outside of the function, it's a vertical translation. If you're adding, it moves up. If you're subtracting, it goes down. Okay, and then the final piece that we haven't really done yet, we haven't done an example like this yet, but this a, if we have a multiplier out front, remember that you have to multiply all of your answers by that thing. So if that number is, if it's less than 0, if it's negative, it's going to flip the whole thing upside down. Okay, so that's what this is saying. If that a value is greater than 1, it's vertically stretched. And if it's between 0 and 1, it's compressed vertically. So we call them vertical shifts here because they're happening outside of the function. Okay. So for 2, it says graph the function, state the domain and the range. For this guy, notice what we have here. We have a multiplier, and we also have a shift. The shift happened, what makes that go to 0 would be -4. So this is going to be shifting to the left by 4. So let's just go ahead. Again, if you don't see it, you can start plugging things in there. Just be careful because you got to get to the beginning, right? So if you started by plugging like a 0 in, for instance, 0 plus 4 is 4. Square root of 4 is 2. 2 times 2 is 4. So at 0, we're at 4. That's a legitimate point, but that's not our starting point. Okay, whatever makes this go to 0 is our starting point. So let's plug in what makes that go to 0. If I go to -4, -4 plus 4 is 0. Square root of 0 is 0. 0 times 2 is 0. So at -4, I'm at 0. Okay. Then if I plug in, let's plug a -3 in. If I plug a -3 in, I would be at 1. Square root of 1 is 1. 1 times 2 is 2. So at -3, I'm at 2. Okay, so I have that going on. And you can kind of see what this picture is going to look like. If you wanted to get one more point, you could. The next nice number to plug into this thing would be a 5, because the square root of 9 is 3, right? So 3 times 2 is 6. So at 5, I'm up at 6. So that's where my next point would go. Okay, and there's a nice picture. The domain of this thing would be the x values where x is greater than or equal to -4. Y values happen at 0, or y is greater than or equal to 0. And we're done. Okay. For 2b, notice we have something that's 1/4 here. Let's see what that does to our picture. We also know that we're going to move up 3 and we're going to move back, to the right by 5. So if I plug a 5 in, 5 is what makes this go to 0, therefore 5 is the starting place. Okay, so if I plug a 5 in, I get 0. 0 times 1/4 is 0. 0 plus 3 is positive 3. So we're going to start our graph right there. Okay, if you plug a 6 in, 6 minus 5 is 1. Square root of 1 is 1. 1 times a fourth is just a fourth. 1/4 plus 3 is 3 1/4. Okay, so at 6, we're at 3 1/4, somewhere in there. All right, now let's choose some nice values so that we don't get fractions inside of the radical there. The next one that I'd want is possibly the square root of 4. So what would make that thing go to the square root of 4 would be a 9. So if I plug a 9 in, 9 minus 5 is 4. The square root of 4 is 2. 2 times a fourth is a half. A half plus 3 is 3 1/2. Notice how I just plugged that in there, did that mentally. So 9, 3 1/2, somewhere in here. So we can kind of see what's happening here. We don't need to get too many more points here. This thing has really, and the vertical level, on a vertical level, this thing has compressed, right? Here was a vertical stretch. Here was a vertical compression, where this thing just, there's like a weight that was put on top of it. And that's because we're multiplying everything by a fourth, so all the y values are getting smaller. Okay, so the domain for this. The domain, we started with the thing that makes this go to 0 is 5. So x values where x is greater than or equal to 5. All right, and then the y values started at 3. So y values where y is greater than or equal to 3. And then we have one of these real-world problems. And I think, remind me, I'll do this one with you in class. And inequalities would be the last thing that we need to get into. So it's the same as always for an inequality. This thing represents shading, and it represents dotted versus solid lines. So remember, if it has a line under it, it's a solid line. And then if the y values are bigger than something, then we know we're going to shade above it. And if it's less than, the y values are less than something, we know we're going to shade below it. Okay, so let's look at this. For this guy, if I plug a 0 in here, notice it's the square root of 1. Right, so if I plug a 0 in for this one, 2 times 0 is 0, 0 plus 1 is 1, square root of 1 is 1. So at 0, we're at 1. Okay, if I plug a, let's plug a, what should we plug in here? If I wanted to make this go to 4, that would be kind of weird. Let's go ahead and plug a 4 in. If we plug a 4 in, 4 times 2 is 8 plus 1 is 9, square root of 9 is 3. Notice I chose that so that I can get a nice number out. So at 4, I'm at 3. Okay, the next perfect square there would be 16. How can I make that go to 16? That's not as easy, is it? Let's see here. What would be the next? Well, let's just see. So if I said 2x plus 1 is equal to 16. If I want that to equal 16, we'd have 2x is equal to 15. So x is equal to 7.5, right? So if I plug in a 7.5, I can get a 16 out. Okay, if I get a 16 in there, the square root of 16 is 4. So that's 7.5. Here's 7, 7.5, I'm at 4. That should be enough. Now, I'm going to connect this with a solid line. Okay, and then since the y values are bigger than this thing, I'm going to shade up above. So that's example 4. Example 5, we have y values less than. Notice it's not less than or equal to, right? So this negative out here means the whole thing's going to flip upside down, which we haven't done yet, so that's a good one to do, and this will be the last one we do. So let's just go ahead and make an xy table. If I plug a if I plug a 0 in, I'll get the square root of 2, which is kind of a nasty number. If I plug a negative 1 in, well, let's just plug a negative 2 in, where it starts, right? If I plug a negative 2 in, I get 0. Negative 0 minus 4 is negative 4. So at negative 2, I'm at negative 4. That's my starting place. If I plug a 0 in, I get something that's ugly. If I plug a 1 in, it's ugly. If I plug a 2 in, okay, let's look at that. Let's see if that's in our domain. It looks like it is. So 2 plus 2 is 4. Square root of 4 is 2. but then I have to apply the negative on the outside. So it's negative 2 minus 4, which is negative 6. So at 2, I'm at negative 6. Okay, the next perfect square here would be if I plug a 7 in, I can get a 9 in there. Okay, so at 7, I have the square root of 9, which is 3. Negative 3 minus 4 is negative 7. So at 7, I'm at negative 7. And that gives me an idea. Now, before you connect these, look again at the inequality. We see that this is supposed to be a dotted line. Okay, so don't forget to dot that. And then it says the y values are less than this thing. Okay, so we're going to shade underneath. All right, and we're done. So that's how you do an inequality with the square root function. And that's the end of this lesson. Okay.